Morning, everybody. I trust you guys had hopefully good weekends. All 8 of you. Woohoo. Morning, Mitchell. Morning, space engineering student. Morning, Michael. Did you guys have a good weekend? Did you do anything for fun in the warmer weather? I planned out my garden space. Morning, FT Remy. Why is there a blue crown next to your name? What does that indicate? I know it's a Twitch thing, but... Twitch Prime. Oh, okay. What's Twitch Prime? Like, paying for service? What does Twitch Prime give you? Are there ads on Twitch? I don't know. Interesting. All this fun stuff. All these subscription services. Oh. Sorry. No one did anything fun this weekend? Did you do homework all weekend? No. So... McDonald's salad. I had a Big Mac for the first time like 2 months ago. It was pretty good. For the homework, this problem is supposed to be done by hand. So that means that the problems are going to be done by hand or MATLAB. It tells you which problems should be done by hand and which problems should be done by MATLAB. So problem 1 is done by hand, and problems 2 and 3 are done with MATLAB. You have to do it that way. Let me check the wording on that. Yeah, so it says done by hand, problem 1, or done using MATLAB, problem 2 and problem 3. It tells you which problems should be done. So Michael went to McDonald's. The rest of you guys stayed in your rooms, did nothing. It's fine. Stared at the computer more. Scammed by Taco Bell? Oh, that's too bad. That's exciting. Girlfriend came to visit. That does count, Squiddy. That's great. That's great. Something for fun. Something. Sometimes you just... There are times... There are frequently times where I just sit down and I just scroll through Reddit for no particular reason other than the fact that I just need to stop thinking about other things. And so binge watching a TV show is a great way. Even though you're technically still looking at a screen, it's just what my husband and I call no-opping. No operation. There's just nothing going on where your mind can just take a break. For problem there's a reason in the first 2 rows it goes to 12 and then switches to 17. Yeah, because there's ... Wait, what? Yes, so Flora in the homework assignment, C squared means it's C times C, not element by element operations. AP Cruising, no, you do not need to know how to do Gauss-Jordan elimination right now. We will get to that later on. I mentioned that you don't need to do 3x3s. The textbook just gets ahead of us. For problem 3, is there a reason in the first 2 rows of the matrix it goes... Oops, that's a typo. It should go A12 or A117, A217. Sorry, I did not change that. Last year's problem only had 12 unknowns. You guys get 17 because you're special. Sorry, that's just a typo. K gross. KO. It's a lot of letters in there. Okay. It's 11:30. Let's begin. So I went over you guys' quizzes and your responses. Thank you guys very much for your feedback. I really appreciate telling me what works, what doesn't work. It seems like it's across the board. At least those who took the quiz. Those who didn't give me feedback are probably the ones that, yes, so Nick, there's something off with Zybooks right now. I just checked. There's a 503 error. I don't know what the issue is. I don't have time right now to email Zybooks and figure out what the problem is, because I'm teaching, obviously. But I don't know. Zybooks is on the fritz at the moment, so I would give it a little bit of time. Hopefully they fix it soon. Okay, so quiz this week. Thank you guys for your feedback. It seems like a lot of systems are set in place that are helping. If there is ever something that you think would help, please let me know. I want to make sure you guys have the resources that you need. I can give you those resources, so I really just give me feedback. But it seems like a lot of options are there for you guys. Just keep in mind with all of your assignments, a lot of it's just repetition. So you get content from lectures, you get content from the Friday videos, you get to practice the content with your textbook, with homeworks. A lot of it's just repetition, so maybe presenting things in slightly different ways. So just keep that in mind. I'm glad I put together a Discord server. It's very useful for you guys. I can see that, which is great. Once again, just let me know. Let me know. One thing to mention is that, nope, wrong one. Is that your homework solutions are posted on UB Learns. So if you go to UB Learns and you just go to the week by week content, I posted them right here. So you'll be able to easily see what all of the homework solutions are. They're just, once again, another link to Box, just because. So the one that's probably of most interest to you guys is homework 3, which is the one you just turned in. Your grade should be released relatively soon. Hopefully we fixed all of the grading issues. But you guys can see that how I wrote the solution. So I did write these solutions. We're getting to the point where there's multiple ways to do something. So this is the way that I did it. You may have done it differently, and that's completely fine. Specifically when it comes to working with arrays, modifying arrays, changing things, it's just a lot of practice, different ways to see things. Here is the solution for problem 1, for problem 2, for problem 3 with corners. You can see how the different indexing was done with the different variables. So there's n, lots of things in here. So you might want to, if you didn't understand what happened, you can check the solution, see how I did it. So Benny, the way you check is by running my code versus running your code. So you can run your code, run my code. If it produces the same numbers, then you're fine. There's not an issue. If you, or by just understanding what is happening. So stepping through, okay, this is what this one does. Then what did yours do? So here's how I did the square array, where I created the vectors or created the matrices and then concatenated them all in one line of code. Maybe you did it in 4 lines of code, still fine. 5 lines of code, still fine. Maybe you didn't use the ones function. Maybe you did it, you created A with zeros and then indexed it. So as long as we end up with the same numbers, then it's fine. There's not an issue. But that is a good question. So yeah, you just run my code, run the solution code, and then run your code. If it gives you the same numbers, you're fine. Okay, so all the solutions are there right now. I don't know exactly, I can't guarantee to have them up immediately after the homework is done, but they should be up relatively soon after the homework is submitted. Okay, other things to mention. So indexing arrays, like I said, some of you guys mentioned that you're still struggling with this. Like I said, it just takes time. You're going to be exposed to arrays throughout the rest of the time we're doing MATLAB and your project. So keep in mind, we're looking at our left-hand side and our right-hand side. Our left-hand side is where we want to store things. So do you want to store it in the whole matrix, part of the matrix, which rows, which columns, which elements? So keep that in mind, where in the right-hand side is what do we want to store there. So just keep that in the back of your minds. You'll see more examples. You'll see as we go on. So just try and continually understand what is happening. If you don't understand it, go to office hours, ask it in class. But you'll see more examples, so you'll get more practice as we go along. For last week's material, some of you guys mentioned the inverse. So this is our equation for the inverse of a matrix. A inverse equals 1 over the determinant of A times A adjoint or A adjugate. For a 2x2, here's our formula. For a 2x2, so A looks like this, A, B, C, D. The determinant is going to be AD minus BC, or CB, our little fish method. And then the adjoint is A and D switch places and B and C change their sign. So written out, this is essentially our formula for a 2x2 inverse. For anything bigger than a 2x2 right now, use MATLAB, where you can use the inverse function in MATLAB, or you can just type A caret -1. Both of those will get you the inverse in MATLAB. We will get to 3x3s and bigger later on in the semester, but for now, you only need to worry about a 2x2 by hand. And in MATLAB, anything bigger, use your inverse function. Okay, then there's questions on when to use matrix math versus when to use element by element operations. So a plain asterisk, a plain division, and a plain caret, these are matrix math. So remember, this is matrix multiplication, this is matrix multiplication with the inverse, and this is matrix multiplication with its A times A times A times A, etc. Keep going. For the most part for this class, if you are explicitly doing linear algebra on paper, that is when you would use these operations in MATLAB. Or when you're solving systems of equations, where you put together A, you put together B, you write this out on paper, you enter in A into MATLAB, you enter in B into MATLAB, and you type this beautiful line of code. X equals A left divide B. If you are not solving a system of equations or not doing linear algebra on paper, you're pretty much doing element by element operations, where you're taking the first number in A, first number in B, doing an operation, second number in A, second number in B, doing the operation. That is where you have the dot, asterisk, dot, division, dot, caret. So for these types of problems, you're going to write out your expression as if you had scalars. So just like we did in week 1 to 2, just write it out using scalars. And then you're going to modify it for element by element operations. So go through it and put a period in front of all your asterisks, all your divisions, and all your carets. So yeah, Benny, don't worry about the 3x3s right now. Your textbook is a little bit ahead of us. Don't worry about 3x3s. We will get there later. So if you're not explicitly doing linear algebra stuff on paper or solving system equations, you're more likely doing element by element operations, where write out your expression using scalar notation, just like you did in week 1 and 2, and then go through, put a period in front of all of your asterisks, all of your division signs, and all of your carets. Okay, and then also some clarifications about the quiz for this week. Questions 2 and 3 have more than one answer. It's multiple answers. I did not write that down for some obscure reason. It wasn't clear in the text for the question, and UB Learns didn't tell you that it was a multiple answer question. That's my bad. So if you had issues with that, revisit it after this lectures. And then also, for your feedback, you only need to write it once. A lot of you guys are copying and pasting it or retyping it every time you take the quiz. Don't worry about that. Just type it in once and then forget it. Okay? There's no points assigned with the feedback. It's just the feedback for me. I can download all of your submissions. I can see everything you've submitted previously. So just type your feedback once. Don't worry about typing it into every single attempt. Yeah. Hopefully save you guys some time. Okay. I think I covered most of what the questions were on the quiz. Yes. Okay, let's get into the material. This week, we are focusing on essentially 5 functions: input, display, or disp, fprintf, load, and save. Load and save are very similar. So we're focusing on those 5 main functions. All of them have to deal with input and output in MATLAB. So let's go ahead and start with the input function. Let me open up MATLAB. There we go. So I've got my notes on the top once again, and then MATLAB on the bottom. So I've arranged MATLAB like this, where I'm going to type my editor here, command window down here, variables over here, just so we can see a lot of everything that's happening. Okay. First things first, input function. So I'm going to go through a bunch of different examples this week to hopefully illustrate how to use all of these functions. Hopefully it's practical. So the input function, we'll start there. Anytime you see something that says prompt the user, prompt, this should immediately ring in your brain that you need to use the input function. Okay, prompt the user. Prompt means you're going to ask the user for some data, and then you need them to enter in some data. So the thing that allows us to do this is the input function. There are 2 ways to use the input function. A equals input, and then in single quotes, we type out what we want to ask the user for, and then semicolon. The second way looks like this. Input, single quotes, and then I have an additional option, which is just an S in single quotes. So one thing to note, single quotes in MATLAB indicate what's called a string or a character array, or a string array, I think is what I called it in the notes. This is an array full of characters. Like you've got 10 characters, it's an array of letters, of characters. You can also use double quotes. This will give you what's called a string scalar, and this is new since about 2017. These 2 behave differently. So a string array with single quotes is where you have X number of characters. A string scalar with double quotes is a 1-by-1. It's literally just a scalar of that text. I am going to demonstrate all of our examples using single quotes. For the purposes of our class, it shouldn't make a difference which one you use, but they are different, so keep that in mind. Random aside. Not random, but an aside. Okay, so here's the 2 ways to use inputs. One with the S and one without the S. We are going to choose this first one when we are expecting the user to enter in numerical data. And we use the second one when we expect the user to enter in text data. When they're entering in words, essentially, text. Those are our two options. Okay, so let's go back to our prompt. It says prompt the user to input the following variables from the command window using the specified prompt. So here's my prompt. That's essentially what you are printing out to the screen for the user to see. So I have 4 things. I want them to enter in the type of fluid, enter in the density, enter in the velocity, and enter in the diameter. The type of fluid is essentially asking them for what kind of fluid, so like water, gasoline, oil, whatever it is. So this is expecting text. So here I'm expecting text. Density in units of kilograms per meter cubed, I'm expecting numbers. In velocity, I'm expecting numbers. And then diameter ratio, I'm expecting numbers. So that means for this first one, I should use this option, B. I should use B. For these all, I should use this first one. Okay, so let's go ahead and see what it looks like in code. Okay, first one first. Enter in the type of fluid. So I'm going to use the input function. So input, open close parentheses. In single quotes, I type in my prompt. I am prompting the user by enter in the type of fluid. There we go. So this is going to be printed to the screen. It's going to wait, ask the user for something. The user is going to enter in something, and then it's going to store the result in the variable that I tell it to. So now I need to say whatever variable. I'll call it variable type. So let me save this and let's run this code, see what happens. So when your program hits the input function, MATLAB is going to stop. It's going to print out the text in single quotes, character by character. So prints out ENTER space IN space THE space TYPE space OF space FLUID colon space. So it prints out that space. And that's important because as the programmer, you need to be overtly explicit about every character that's going to be printed out. There's no spell check in MATLAB. There's no indicator, there's no automatic spacing in MATLAB. You need to be explicit about every character that's going to be typed out. And so input, it's waiting. The program is waiting for me, the user, to enter in something. Very good, AP. So I'm going to enter in water. Notice MATLAB gives me an error because I typed in water. I don't have my S there. I don't have my single quote S. So let me go ahead and kill my code, put in my S, and now when I rerun it, I can type in water, and it works. So now water is stored in my variable called type. So now type contains whatever the user entered in, which is text. Water, note it's a 1x5 because there's 5 characters. Okay, so that's my first one. Then I'm going to ask the user to enter in the density. So I'm going to store this in a variable called row. Input, enter in the density, kilograms per meter cubed. It's numerical data, so I don't need the S. I'm expecting a number for the density. And note, it will print out everything character by character. If I didn't have this space here, it would look like this. So water's my fluid, my density. Note, here there was the space, here there's not the space. So 4, that's not the density of water, that's just there. I keep getting an error for type 1. Do you have the S? Okay, let's keep going. Do you have the comma? So remember, everything needs to be typed exactly the way it is here. Next one, velocity. I'm going to store that in a variable called v. Once again, I'm prompting the user for a value. So I'm using the input function. The prompt I'm using is enter in the velocity. And then in meters per second. Generally, we will tell you what prompt to use, but honestly, you can really prompt the user with whatever text you want. You could just say velocity. It doesn't matter. If we tell you, you should use the text we tell you, but in real life, you can use whatever text you want. If you want them to enter in the data on the next line, you can use \n. So \n is going to print out a new line. It's going to press enter. So it's going to print out enter space in space the space velocity space bracket m \s bracket colon, and then this indicates it's going to press enter and go to the next line. So now I enter in the type of fluid, enter in the density, and now I can enter in the velocity. Note it's having me enter it in on the next line. Wow, 4. And so it's all your preference on how you want things to be printed out, but you need to be aware of everything that's printed out. Be aware of your spacing, be aware of what it looks like to the user, because it will print out character by character. It will not spell check for you. It will not automatically space things for you and align them nicely. That's your job as the programmer. And last one, enter in the diameter ratio, R. I'll store it in a variable called R. It doesn't matter what you store, what these variables are, they're just variables. You can think about these variables similar to your function inputs, where you don't know exactly what the user is going to enter in, but you just know that they're going to enter in something. Assume that it's a valid input. Assume that they're entering a valid type of fluid, a valid density, a valid velocity. And here, a valid diameter ratio. So input, enter in the diameter ratio. I like my space. There we go. I'm prompting the user for 4 different values. The user can honestly enter in anything they want as long as it's valid MATLAB code. So the type of fluid, gasoline, the density, 735, whatever it is, velocity, 5. So those are scalar values. They could also enter in matrices or vectors. So I could do 1 to 10. And notice now in my workspace, R contains a vector of 1 to 10. I could do a matrix, so 24, 35, 67, 13. So now density, or row, contains a matrix, as long as it's valid MATLAB code. I could also write linspace. Linspace also works. Now it creates a vector using linspace. So as long as it's valid MATLAB code or a way to create an array, just like we learned in week 3, technically I think you could also do an expression. It just doesn't matter. It's going to evaluate that code, that input, the same way it evaluates that MATLAB code, and then store the result in whatever variable is entered in from the user. Okay. Now, my next thing is use the input values to calculate the pressure drop using the following formula. So now I can go ahead and use my variables in my calculation, where del P equals 0.5 or 1/2 times 1 minus R squared, that whole thing squared, times rho times V squared. So note, I entered in this expression using as if they were all scalars. However, let's say R is going to be a vector. I would just go through, and in order to ensure element by element operations, I'm going to put a period in front of all my asterisks, all my carets, and all my division signs. There we go. Now I have essentially code proofed this expression to work for arrays and element by element operations. As long as R, rho, and V either are all arrays the same size, or if only one of them is an array, or a non-scalar. Okay, so let's go ahead and run this code, see what happens. So the type of fluid, gasoline, the density, 735, velocity, 5, diameter ratio, 0.9, negative 0.1, 0.1. So now, del P, so rho, V, type, and R were all entered in by the user. And del P is also a vector containing my results. So Flora, it depends on your application. In general, it's not a bad idea if you're not penalized for it. It will work for scalars. It will work for vectors. In theory, if you're writing a program that someone else is going to use, you would also have some checks in place in order to ensure that you can do your operations so MATLAB doesn't give you an error. We'll learn how to do that more next week or the week after. But it's not a bad idea because you're not penalized for it, if that's what you want to do. So once again, it just depends on what you're trying to do. Okay, there we go. That's the input function. So keep in mind, what kind of values are you expecting? If you're expecting text, use your S option, comma, single quotes S. If you're expecting numbers, then just enter in your prompt. The annoying thing about the input function is you need to enter in your values manually every time you run your code. So I like to do something like this. Where I can just enter in values as an example. So that now when I run my code, I have the same set of values that I can use to test it with, and I don't have to type in everything every time. Okay. So just a trick in terms of working with the input function. Okay, that is the input function. It should be relatively straightforward. Anytime you see prompt the user, that means you are using the input function. MATLAB will print out this prompt to the command window. It's going to pause and wait for the user to enter in something. When they press enter, whatever they entered is going to be stored in this variable, and then it will move on to the next line of code. Okay, let's talk about the disp function. So disp is short for display. So using the disp function, print out the following text. So I want to print out all of this text using all of the values that I just entered in from using the input function. Okay, so I'm essentially extending what we did previously. Okay, so if I look at this text, it says I want to print out for a flow of fluid name. Fluid name is going to be replaced by whatever the user entered in for type. With a density of this value, once again, this is going to change depending on whether or not what the user entered in, and a velocity of this value also going to change depending on what the user entered in. The pressure drop across the enlargement as a function of diameter ratio is, and then print out a table. And so in general, the disp function looks like this. Disp, open close parentheses, and then you enter in one single string or one single array. So if it's a single string, you just type it in single quotes. Okay, but we can display one thing at a time. One single string like this, where it's going to print out display text here, or you can print out del P, one single array at a time. So MATLAB already has some default printout to the screen if we leave off the semicolon. So it's going to print out the name of the variable plus the values. We already know that. That's the default display for MATLAB. However, with the disp function and with fprintf, as we'll probably get to on Wednesday, is we now have more explicit control over how we want things printed out. So as a rule, you should put a semicolon everywhere. If you want to print out the values of an explicit variable, use disp. So here I can explicitly say that I'm going to display the values in this array. Del P is a row, so it prints out as a row. If I transpose it, it will print it out as a column, which as you can see displays much nicer. But keep in mind, display only prints out one single line of text, one single string, or one single array. We can, not trick, but we can also combine those two. However, we need to do it by creating a new array. So if we want to combine both text and variables, we're going to add a new array where we're going to do brackets to indicate we're combining two things or three things, and we're going to put text in with variables. So let me go ahead and demonstrate how we're going to do this by printing out our first line of code here, or our first line of text up here. Okay, so I'm going to use the disp function. Notice this line of text has this here and this here, which means that I'm going to insert some data that is variable depending on what the user entered. So that means I need brackets because I'm combining text with some variables. So first thing I'm going to print out for a flow of. Next to that, I'm going to print out the data stored in the variable type. So I just type in type there. So I'm printing out FOR space A space FLOW space OF space. Then I'm inserting the data stored in this variable. Just going to print it out. Next to that, I want with a density of, and then I'm going to insert some more data. Insert the variable or the data stored in row. Then next to that, kg divided by meter cubed and A. There we go. So now I am creating a new array by combining text. I'm printing out for a flow of space. The data stored in type is going to be printed out next. Space with a density of space. Then the data in row. Then space, kg slash m caret 3 and A. So now when I run this, it prints out for a flow of, inserts gasoline, because that's what's stored in type, with a density of x kg per meters cubed in A. So it turns out that if your variable stores text, there's not an issue. However, if your variable stores numbers, you need to convert it to text using num2string. Good question, Sophia. I'll mention that in a minute. So row contains numbers, so it prints out with just an X here for some obscure reason. It doesn't give you an error. So you just need to convert it to string by using the num2string function. So you just type num2string and then open close parentheses. So now it's going to convert this numerical data to string and print out the number. Sophia asked, what if we don't have the brackets? It's going to give you this cryptic error that says invalid expression. Check for missing multiplication, blah, blah, blah. To construct matrices, use brackets instead of parentheses. So remember, the disp function can only print out one thing at a time. One text, one string of text, continuous string of text, or one array. So here it's trying, it essentially has 5 inputs. It's essentially as if you had this function like this, where you sent it 1, 2, 3, 4, 5 pieces of information versus just one piece of information. So you need the brackets. No, don't put commas. You don't need commas. You can, but you don't need commas inside of this. So there we go. So we're combining this text with this whatever stored in this variable, with this text, with whatever stored in this variable, and this text. So note, if I changed type and row, it will now print out the new values. Okay, so we printed out the first line. Woohoo! One line down. Let's print out the second line. To print out the second line, I need a new display command, display function. So once again, I am going to combine text with whatever my value is for velocity. So I'm going to create brackets. And I'm printing out velocity of space the value stored in V, followed by space, meters per second, the pressure drop across the enlargement. There we go. Remember though, V is a number, so I need to convert it to text with num to string. So now here's my first line, here's my second line. It enters in the number that was stored in V. Note, I have all these spaces surrounding my variables. If you didn't have those, it wouldn't insert them in. So things would be squished together. So it would be for a flow of gasoline with density of 735 kilowatts. So you need, like, it prints out character by character. So if you are creating type like this, yes, you would need the single quotes. However, if you entered in the gasoline with input, you do not need the single quotes. That's what this is here for. Let me put my spaces back in. Okay. I've entered in my first two lines. Now entered in my third line. So for my third line, it's just regular text, so I don't need the brackets. I can put them in if I want to, but I don't need them. So I'm just printing out as a function of the diameter ratio is. There we go. So I've printed out, whoops. Printed that out. So I've printed out my 3 lines of code. Or my 3 lines of text, sorry. Where I've inserted whatever is stored in type, inserted whatever is stored in row, and inserted whatever is stored in V. Yay! So that's how you would do it if you were using disp. Okay, so I've printed out my first 3 lines. Let's go ahead and print out this table. Let's print out this table. So this table has 2 header lines. It has diameter, pressure drop, and then ratio and PA. And then here are my values from R, and here are my values from del P. So to print out the header lines, it's not that big of a deal. It's just text. So I just display. Hold on. Diameter and then pressure drop. So it's just text. Diameter, pressure drop is just text. So I just print that out. So Flora asks, for the second disp, why did we use num to string if it's a different disp? So for 10 here, so num to string is used because V contains a number. So anytime your variable contains a number, you need to convert it to a string. It has nothing to do with the fact that it's a different disp function. It has everything to do with the fact with this being a number. So I've printed out that header. I've printed out that first line. Let's print out my second one. Once again, my second line, it's just text. So I just print out PA. There we go. So let's run that. Note, diameter, pressure drop. It prints out character by character. So starting from the wall, I guess if you can call it, the beginning of the line, it prints out diameter space pressure drop. If you want to shift things over, you just space it. So if I want ratio to be aligned with diameter like that and pressure PA to be aligned like this, I just space it out. So now it adjusts it. So a lot of this for disp and fprintf, you just type it, see what it looks like, go back, change it, see what it looks like, go back, change it, see what it looks like. So maybe I want PA to be over 1 more. Okay, never mind, I'm not happy with that. Back to run. So you just change it around and shift to wherever it matches. Okay, so I printed out my first header line, my second header line. Now I want to print out the value stored in R, placed next to the values stored in del P. So let's go ahead and see if we can print out the values stored in R. Let's just say disp R, see what happens. Okay, there we go, disp R. It prints out the first header, second header, and then it prints out the values stored in R as a row. If it looked like this, it would look like that. I don't want them in a row. I want them in a column. So I'm just going to transpose it so that it's now in a column. So there we go. Now I've printed out my values in a column. It's not aligned with my header, so I'm just going to move my header over. Space a bunch. Press run. That lines up much better. Quite not still, it's not centered, so let me just space it over a little bit more. See what it looks like. There we go, that's centered. So I have the values in R printed out as a column underneath my header. Yay! Now I want to do the same thing with my values for del P. Okay, so let's just start by printing out disp del P. What time's class end? Do we still have 10 more minutes? Yeah, we do. We still have 10 more minutes. So notice it prints out the values in R. Immediately below that, it prints out the values in del P. Del P is a column, or is a row, so it prints it out as a row. So I don't want that. I want it as a column. Okay, so still don't really want that. It prints out the first header, the second header, the values in R directly on top of the values in P. I don't want them on top of each other. I want them next to each other. If you want to print out 2 different variables or 3 or 4 or whatever next to each other, you need to create a new array. So I go to disp. I'm going to create a new array. In here, I'm going to tell it what to print next to each other. I want to print the values in R next to the values in del P. So it's a new array. The values in R are going to be next to the values in del P. So now we can see that my values in R are printed out as a column immediately next to my values in del P. Pressure drop isn't aligned. Okay, so now I'm going to go ahead and adjust my header. So maybe I want PA to be over by 1 or 2, pressure drop to be over by 2, run it, see what that looks like. And adjust as I need to. So, Jalen, that's a really good question. So I don't need to convert them using num to string because it's only variables here. So I use num to string here because I'm combining text or combining strings with numbers. Here, I'm just printing out the values in my array. There's no text here, so I don't need to convert it to text. So here I convert to text because I'm combining both text and numbers. Here is just numbers. It's a good question. Also keep in mind, num to string, it technically can work on arrays. However, I strongly encourage you guys to only use it for scalars. There are other ways to print out arrays with text using fprintf that are much better, more control. Okay, let me show you something. So here I'm using format to readjust the default format. Notice when I do that, my array prints out differently. My header files, or my headers aren't adjusted, so let me go ahead and readjust those. See what it looks like. I'm still not centered. Readjust it, see what it looks like. Trial and error. Pressure's over too far. Adjust it, run, keep going, adjust it, see what it looks like, etc. However, these numbers, they're in scientific notation. This 1 to the 3rd applies to all these numbers. I don't like that. I want my numbers to look like, where is it? This. I want them to look better. With disp, we don't have as much control over how the numbers are displayed. It's going to use whatever default options that are built into our command window that we have using the format function or the format command. If you want to change that, where you run into a situation like this, all you need to do is just type format short G. Short G changes it so that each number is independently printed out using the shorter of the two, whether or not it's scientific notation or not using scientific notation. So if I do format short G, that's where I get my numbers printed out like this. But I have no control over how many digits past the decimal point. It's going to be either until you hit a bunch of zeros or 4 digits past the decimal point for format short G, or for format short. Once again, my header isn't aligned, so I just realign it. The nice thing about the font used for programming, it's called Courier New, is each character takes up the same amount of space. So if I do a space here, it will automatically align it with the character above it. So if I want, so here this point, this 9 here is aligned with this N on function, I can use that as a reference and say, I want that to be the center. So I can adjust it so that I can use that as a reference, and we'll see why that matters when we get to fprintf. Same thing with pressure drop. It's not centered, my PA, so I'll just move it over, adjust it, see what it looks like until I'm happy. So that's how we can use the disp function to print out a single line of text, to print out a single line of text combined with data stored in variables, or print out a table of values. Okay. So moving forward in your code, you should have a semicolon after every single line. And then you should start using disp or fprintf to explicitly print out the variables and the values that should be printed out to the screen with purpose. Oh, another thing is, like I said, disp, we don't have a lot of control over how the numbers are printed out. Like I said, I have no control over how many digits past the decimal point. Apparently, format short G prints out at most 5 numbers, which is fine. I like to use disp when it comes to debugging to print out different variables in different locations. However, this is only one of our display functions. We also have fprintf. So, let's say that, come on, it's way too far. Let's say I want to print out the same text using fprintf. Okay, so let's do that. Same text using fprintf. Similar ideas. However, it's a little more complicated. And when I say a little more complicated, we can get a lot more complicated with fprintf. It doesn't mean it's going to be complicated. It just means fprintf gives us a lot more control over how we want things printed out. However, when we have a lot more control, that means we need to be way more explicit about every little thing. So one thing to note about disp is every time it prints something out, it's automatically going to press enter when it is done. So it prints out all of this text, and then implicitly listed in here is a new line character where it's going to press enter. fprintf, however, we have a lot more control, which means we have explicit control over when we want the \n or when we want the new line character to appear. So for this first line, if I wanted to repeat this using fprintf, I'm going to type fprintf, open close parentheses. We never need to use brackets for our string, but then we enter in a string. So I type in for a flow of. Now, if I want to insert some data in a variable, I'm going to use what's called a formatting, what is it called? A format operator, where it's a %sign. And then I need to indicate what type of data I want to enter in. So fluid name is text. So there's 4 main options. A %s is used when we want to enter in text. A %, 3 main options. A %f is when we want to integrate numbers, specifically floating point numbers or non-whole numbers. And then %d or %i, either one, when we want to indicate numbers, whole numbers specifically. I encourage you guys to really stick with these two. Those are the 2 main ones you'll be working with, %s and %f. And even then, mostly %f. So if fluid name is going to be a string or text, I use a %s. And then I follow it with a density of, and then I'm going to insert a number. So if it's a number, I use %f. And then kg, meters cubed, and a. So this will print out the same thing as this, where it's going to insert a string here and insert a number here. Now I just need to tell it where those variables are. My string is in variable type and my number is in variable row. So type corresponds to the %s and row corresponds to the %f. So it's very similar. It's very similar. It's just different syntax. So now it's printed out like this. Note, there's no new line character. It just prints out A and then stops. Display, however, pressed enter. So if I want to explicitly identify that I want to press enter, I just say \n, and now it will press enter, and my prompt is down here. My input next line is down here. Okay, we're gonna go ahead and stop there. There's a lot more when it comes to fprintf, so we are gonna focus a decent amount of our time on fprintf on Wednesday. But hopefully this clarified display a little bit. Okay, with that, I am done. Any final questions? We're getting into the more heavier programming topic pieces, less just calculations, so it's going to be a little bit different. Yes, so AP Cruzy, that's a really good question. You need to do it in order. So it will insert the first % goes with the first variable, second % goes with the second variable, etc. And like I said, we will get to that. There are some caveats to that, but we will get to that more on Wednesday. Good. I'm glad I clarified some stuff. Like there are I'm trying to be as practical as possible with lecture, because students do tend to have some, like there's difficulties that arise with this material. So I'm trying to be as practical as possible to clarify how to do things. So hopefully all this makes sense. Any final moments, points, questions, comments? Okay, week 5, we can do it 1 week at a time. I'll see you guys on Wednesday.